All right, so you want to dive into this whole AI thing? Well, get ready, because we're about to take the plunge.
Sounds good to me.
I think a lot of people are kind of in the same boat, right? Like, curious about AI, but not really sure where to even begin.
Yeah, I can definitely see that.
So we're going to try to, like, unpack this whole complex field for you, get a handle on the history, the big ideas, and what to really watch out for as AI keeps, well, advancing.
Makes sense.
And to do that, we've got a fantastic chapter here from Peter Norvig's book.
Great book.
So hopefully by the end of this, you'll have gone from like AI curious to, I don't know, at least a little bit AI savvy.
Definitely.
One thing that always kind of trips me up is, well, it's just the definition of AI itself.
Uh-huh.
It's such a buzzword these days.
Oh, yeah, for sure.
But can we really like pin down what it actually means?
Right.
It feels kind of slippery,
Yeah, I mean, the term AI definitely gets tossed around a lot.
For sure.
And I think actually it's less about like perfectly mimicking human thought
Oh, interesting.
and more about building systems that can make smart choices
Okay.
to achieve goals.
Gotcha.
And we call these systems agents.
Agents. Okay. So instead of trying to like replicate consciousness,
Yeah,
it's more about creating something that can, I guess, act effectively in the world.
that's the heart of it. Yeah,
So that's why we hear about acting rationally as a core concept in AI.
exactly. Exactly.
Okay.
It gives us a way to actually define AI, like mathematically,
Oh, that's interesting.
so we can measure progress. And it's not just a computer science thing either.
Really? I always thought of AI as like all algorithms and code.
Sure, that's a big part of it,
Yeah.
but it's broader than that.
So where else does it pop up?
Well, think about it. Anytime you're trying to, say, control a system to minimize costs
Okay.
or like optimize resources to get the maximum benefit,
Right.
it's all about making smart decisions based on data.
Makes sense.
And we see this in fields like economics and statistics too, right?
Mm-hmm.
Using models to kind of guide actions.
So AI is kind of like a supercharged problem solver, pulling ideas from all these different fields.
Yeah, I think that's a great way to put it.
But I'm curious, how did we get to this point?
Yeah.
Was AI always this practical, or were there times when things went a little, I don't know, off track?
Oh, it's definitely been a wild ride.
I bet.
Early AI research, like back in the 1950s,
Okay.
was just brimming with optimism.
Really?
Oh, yeah.
So, like, what were they thinking back then?
I mean, people thought we were on the verge of creating, like, super intelligent machines.
Wow, right off the bat.
Yeah, like right away. Herbert Simon even predicted that a computer would be the world chess chop within a decade.
Wow. Okay, talk about ambitious. But that didn't quite pan out, did it?
Not exactly.
Yeah.
I mean, there were some early wins, for sure,
Okay.
but the progress just didn't live up to the hype.
And that's when those, what were they called? The AI winters hit.
Exactly, the AI winters.
What happened during those periods?
Well, imagine, like, a sudden drop in funding and a drop in interest in AI research.
Oh, so people just kind of lost faith.
Yeah, pretty much.
Why? What happened?
Well, it turned out that early AI systems had some serious limitations.
Oh, okay.
They just couldn't handle the complexity of real human intelligence.
I see.
And we definitely underestimated the computing power that we would need.
To make those big AI dreams a reality.
Yeah, exactly.
So it's like trying to build a skyscraper with twigs and mud, basically.
Pretty much.
So how did AI, I don't know, thaw out from these winters? What sparked this resurgence that we're seeing today?
Well, there were a few key turning points.
Oh, okay.
One was the emergence of what we call expert systems in the 1960s.
Expert systems. Okay.
These were systems that were designed to tackle specific problems
Gotcha.
by using knowledge and rules.
Hmm.
So, like, for example, there was this system called Dendril
Dendril. Okay.
that could analyze molecular structures better than, like, human experts could.
Wow. So instead of trying to create like a general purpose intelligence, they were like, okay, let's just focus on mastering one specific skill.
Exactly. It was a much more targeted approach.
Makes sense.
And it yielded some pretty impressive results.
I see.
And then, in the late 20th and early 21st centuries,
Okay.
we saw the rise of machine learning.
Ah, yes, machine learning. That's everywhere these days.
It really is.
But can you remind me, what is it exactly? What makes machine learning so different?
It's basically the idea that computers can learn from data
Okay.
without being explicitly programmed for every scenario.
Okay, so like instead of giving a computer a step-by-step manual,
Yeah,
we're kind of saying, hey, here's a bunch of data, figure it out.
exactly.
It's like teaching a kid to ride a bike.
Uh-huh.
You don't give them like a step-by-step manual. You let them kind of learn by doing, falling a few times.
Yeah,
get better with practice.
That's a great analogy.
So that's machine learning, but then there's also deep learning, right? I've heard that Nuger can do some pretty amazing things, like recognizing images, but what makes deep learning so powerful?
Well, one really dramatic example was the 2012 ImageNet competition.
ImageNet.
A deep learning system basically blew the competition out of the water
Wow.
when it came to recognizing images.
So it was kind of a turning point.
Oh, absolutely. It was a pivotal moment for deep learning.
So image recognition was just the start.
Yeah, just the beginning.
What else has deep learning tackled?
Well, it's been revolutionary for things like speech recognition,
Sure.
translation, medical diagnosis, and even game playing.
Speaking of games, wasn't there a big story a few years ago about AI mastering Go?
Oh, yeah. AlphaGo.
AlphaGo, right?
Powered by deep learning.
Wow.
Defeated a world champion Go player.
I remember that.
It was a huge milestone, you know?
Yeah.
Showed just how powerful these techniques could be.
Okay, so we've got a sense of what AI is
Right.
and kind of the twists and turns it took to get here.
Yeah.
But now I'm curious about the how. How do we actually build these AI systems that can make these smart, rational decisions?
Right.
Where do we even begin?
Well, I think the foundation of any AI system is understanding how it interacts with its surroundings, its environment.
So the environment. Okay.
Now, we need to think about the agent
Okay.
and its environment.
Okay. That sounds a bit abstract.
It can be, yeah.
Can you break it down for me a little bit? What exactly is an agent in this context?
Sure. So an agent is basically anything that can perceive its environment
Okay.
and then take actions to change things.
Okay.
So a simple example would be like a thermostat.
A thermostat.
Yeah, it senses the temperature, and then it turns the heating on or off.
Oh, so that's an agent.
Yeah, that's an agent acting in an environment.
Huh. So even something as simple as a thermostat
Right.
can be considered an AI agent?
In a sense, yeah.
That's pretty cool.
Of course, they can get way more complex.
Right, I imagine.
Like, think about spam filters deciding which emails to block. Or, self-driving cars navigating through traffic.
Oh, yeah.
So those are all examples of AI agents.
Okay, so these agents are constantly taking in information
Yeah.
and making decisions
Right.
based on their goals and the environment they're in.
Exactly.
But how do we design them to actually make those decisions effectively?
Right.
Is it all about, like, complex calculations?
Well, let me try to illustrate how this works.
Okay.
With a classic AI scenario
Right.
that we call the vacuum cleaner world.
Okay, vacuum cleaner world. I'm intrigued.
So just picture a robot vacuum cleaner
Okay.
in a room, and it's trying to figure out how to clean up all the dirt.
Okay, sounds pretty relatable.
It might sound simple, but it actually helps us grasp some core AI principles.
Gotcha. I use a robot vacuum cleaner at home, so this is hitting close to home.
Perfect. So first we need a way to measure how well the agent is doing. Right?
Okay, yeah, you need to be able to keep score
Yeah.
to
Exactly.
know if it's doing a good job.
So in this case, it's like how much dirt the vacuum picks up.
Okay, makes sense.
That's the performance measure.
The performance measure, all right?
So we need a way to tell if our AI is actually succeeding.
Right, at its task.
Exactly.
Okay.
Then we need to think about the environment.
The environment. Okay.
So for our little robot vacuum, is it a fully observable environment? Meaning it can see everything?
Oh, okay.
Or is it partially observable? Like if you can't see under the couch.
Right.
So that matters a lot.
Yeah, my robot vacuum definitely bumps into things sometimes, so I guess that means its environment is partially observable.
Exactly.
What else do we need to consider about the environment?
Well, is it deterministic? Meaning that the outcome of each action is predictable?
Okay.
Or is it non-deterministic, where things might happen randomly?
Okay, so deterministic versus non-deterministic.
Yeah, think about a self-driving car.
Oh, right.
It can't perfectly predict what other drivers are going to do.
Nope, definitely not.
So its environment is non-deterministic.
Right, that makes sense.
It's a lot trickier.
So it seems like there are a lot of factors that go into designing an AI agent,
Yeah.
not just the algorithm itself. Right.
Yeah.
It's like sending an explorer on a mission,
Right.
You need to give them the right tools and knowledge to navigate the terrain.
Exactly.
So what are some of the tools in an AI's toolkit?
Well, one of the most important ones is the ability to search.
Search. Okay.
A lot of AI problems involve finding a sequence of actions that lead to a goal.
Okay.
And that's where search algorithms come in.
Okay, so like finding the shortest route on a map.
You got it.
Okay.
It's all about exploring a space of possibilities and finding the best path.
To the solution.
To the solution, yeah.
Okay.
So let's stick with your map analogy.
All right.
Imagine you're trying to get from point A to point B.
Okay.
The map represents the state space,
The state space.
showing all the possible locations you could be.
Gotcha.
And the roads connecting those locations are like the actions that the AI can take.
Oh, okay. So the AI is choosing which path to follow to reach its destination.
Precisely.
And a search algorithm is like, what, a set of rules for exploring those paths?
That's a great way to put it, yeah.
So are there different types of search algorithms?
Oh, absolutely.
Like some that are better for certain situations than others?
Yeah, for sure.
What are some of the main types?
Well, we have some that are called uninformed,
Uninformed. Okay.
meaning they don't have any prior knowledge about the problem.
Okay.
They just systematically explore the map.
Gotcha.
So one example is breadth first search.
Breadth first search.
It checks all locations one step away from the starting point,
Okay.
then 2 steps away, and so on.
Okay, that sounds pretty straightforward. But I imagine it could get inefficient if the map is huge, right?
Yeah, you're exactly right, yeah.
Like it would take forever to explore every single path.
Yeah, that's why we also have what we call informed search algorithms.
Informs.
These use what we call heuristics,
Serious.
or rules of thumb, to guide the search toward the goal more effectively.
Oh, so it's like they have a little bit of extra knowledge.
Yeah, a little bit of guidance.
Okay.
So instead of blindly exploring every route, a heuristic might be something like, always head in the general direction of the destination.
Right, like having a compass to
Exactly.
point you in the right direction.
Exactly. And a classic example of an informed search algorithm is a search,
A search. Okay.
which uses a heuristic to estimate the cost of reaching the goal from each location.
Gotcha.
And then it focuses on exploring the most promising paths.
So it's not wasting time on paths that are clearly going in the wrong direction.
Exactly.
This is all starting to click. So these search algorithms are like the AI's navigation system,
Yeah, I like that analogy.
helping them find the best way to solve a problem.
Yeah, exactly.
But are all AI problems solved just by searching?
That's a great question. And the answer is not really.
Okay.
Search is a powerful tool, for sure,
Uh-huh.
but it's not the whole story. To really tackle a lot of real-world problems,
Okay.
we need to equip our AI with something more
Like what?
knowledge about the world itself.
Okay, so it can't just blindly search.
Right.
It needs to kind of understand how things work.
Exactly.
So how do we give these AI systems that knowledge? Is it like uploading a textbook into their digital brains?
It's a bit more nuanced than that.
Okay.
We venture into the realm of what we call knowledge representation
Knowledge representation.
and reasoning.
Okay.
We use formal languages.
Okay.
Think of it like coding with logic
Okay.
to actually encode facts and relationships about the world.
So it's less about giving the AI a textbook
Yeah,
and more about giving it a set of rules or statements that describe how things work.
exactly. That's a great way to put it.
Okay, this knowledge representation stuff is already fascinating.
It is. It's a really rich area.
But we'll have to save that for next time. I'm really eager to hear more about it.
It sounds good to me.
Welcome back. Before the break, we were starting to unpack this whole idea of knowledge representation, how we give AI systems information about the world. Seems like a pretty massive task, to be honest.
It really is. One of the big challenges is just like the sheer complexity of the real world, you know?
Yeah, for sure.
All the objects, relationships, events. Yeah.
It's
It's a huge amount of information to capture.
Right, like trying to cram the entire universe into a computer program.
Yeah.
So how do AI researchers even, begin to tackle this?
Well, one approach is to kind of narrow the focus.
Okay.
So instead of representing everything about the world, we zero in on the knowledge that's relevant to a specific task.
Oh, that makes sense. So, if we're building an AI to diagnose illnesses,
Exactly.
we might focus on, representing knowledge about diseases, symptoms, treatments.
Exactly. So it's like giving the AI a specialized textbook instead of trying to force-feed it the entire encyclopedia.
Right, right. Way more manageable.
Mhm.
But how do we actually write these AI textbooks? What language do we use?
So there are a few different options. One popular choice is what we call first-order logic, which is a way to express statements about the world.
Okay,
That's both precise and flexible.
okay.
So you can say things like, all birds have wings, or, there exists a cat that is black.
Okay, so it's like a structured way to express those facts and relationships.
Exactly.
But isn't logic kind of, dry? Are there more visual or intuitive ways to represent knowledge?
Oh, absolutely. So we also have things like what we call semantic networks,
Semantic networks.
which are kind of like graphs where the nodes represent concepts,
Okay.
and then the links between those nodes represent the relationships.
So like a mind map, but with a more formal structure.
Yeah, exactly. So you could have a node for bird, another for wings, and a link between them that says birds have wings.
I can picture that, yeah. So we can kind of build up these, like, complex webs of knowledge.
Exactly, showing how these different concepts are all connected.
That's cool. Are there other ways to do it?
Yeah. Another option is something called frames,
Frames,
which are
okay.
similar to semantic networks,
Okay.
but they're more focused on representing knowledge about specific objects.
So like a template with slots for different attributes.
Yeah, you got it.
So a bird frame might have slots for like color, size, habitat, and
Yeah.
flying ability.
Exactly. And
Oh,
each slot can have like a default value.
okay.
It can be overridden with specific information.
Oh, that's neat. So like the default value for flying ability in the bird frame might be true,
Right.
but we could overwrite it to false for a penguin.
Exactly. Exactly.
That's really clever. So with all these different options, logic, semantic networks, frames, how do AI researchers choose the best one?
It really depends. I mean, there's no one-size-fits-all solution.
Right.
The choice often hinges on the specific task, the type of knowledge, what kind of reasoning we want the AI to do.
So it's kind of like a toolbox, each tool with its own strengths and weaknesses.
Exactly.
You
Exactly.
wouldn't use a hammer to screw in a light bulb.
Right, right.
This knowledge representation stuff is really fascinating.
It is. And it's a very active area of research. People are coming up with new ways to capture and represent knowledge all the time.
Well, now that we've explored how these AI agents get their knowledge, I'm thinking back to the environments they operate in.
Right.
We touched on this before, but can we dive a little deeper? Like, what are some of the different types of environments that AI has to navigate?
Sure. The type of environment really makes a huge difference in how we design and build an AI.
Okay.
So one fundamental distinction is between what we call fully observable and partially observable environments.
Okay, so a fully observable environment would be like a chessboard
Yeah,
where the AI can see the whole board at any time.
exactly. It has all the information it needs to make decisions.
But a lot of real-world situations are only partially observable, right?
Absolutely. Like your self-driving car can't see what's around every corner,
Right.
and it can't predict with certainty what other drivers are going to do. It's working with incomplete information.
And that makes things a lot trickier, I bet.
Oh, for sure. In partially observable environments, the AI has to make decisions based on what it can see and also kind of factor in the possibility of the unknown.
Makes sense. So what other types of environments are out there?
Another key distinction is between deterministic and non-deterministic environments.
Okay.
In a deterministic environment, the outcome of every action is predictable.
Like a game of checkers, where every move follows a set of rules.
Exactly. But in a non-deterministic environment, there's randomness or uncertainty.
Right, like a card game where you don't know what you're going to draw next.
Exactly. And that makes a huge difference in how the AI needs to make decisions.
Right.
In a deterministic world, we can often use those search algorithms we talked about
Uh-huh.
to find like the optimal solution. But in a non-deterministic world, we need strategies that can handle uncertainty.
Okay, so the AI needs to be able to deal with the unexpected.
For sure.
What other, like, environmental factors come into play?
Well, we also have episodic versus sequential environments.
Okay.
So in an episodic environment, each decision is independent.
Okay.
Like think about a spam filter.
Okay.
The decision for one email doesn't affect the next one.
Right.
But in a sequential environment, past decisions impact future ones.
So the AI needs to have a sense of history. It's not just reacting to the immediate situation.
Exactly.
Okay, I'm seeing the pattern here. Are there even more?
There are a few more. We have static versus dynamic environments.
Hmm.
So a static environment stays the same while the AI is deliberating,
Okay.
like that game of checkers.
Mm-hmm.
But in a dynamic environment, things can change even while the AI is making decisions.
Gotcha. So like that self-driving car again, it can't assume that the world's just going to stay still while it's figuring things out?
Exactly.
Yeah.
It needs to be more reactive, constantly adapting.
Makes sense. This is getting pretty complex.
It is. It is. And then finally, there's the distinction between discrete and continuous environments. So in a discrete environment, there's like a limited number of possible states and actions.
Okay.
Think of like tic-tac-toe.
Right. Limited options. But in a continuous environment, there are just countless possibilities.
Exactly. Like think about controlling a robot arm. There are infinite positions and movements.
Mm-hmm. Okay. So all these different distinctions, observable versus partially observable, deterministic versus non-deterministic,
Right.
it really helps us understand the challenges an AI agent faces, right?
It does. And it guides how we design and build it to succeed in that environment.
Okay, I'm getting a real appreciation for how much goes into building an AI. It's not just about algorithms. It's
Yeah,
about understanding the environment, representing that knowledge we talked about, and choosing the right tools for the job.
exactly.
But I'm still kind of curious about how AI actually learns from data.
Right.
We hear so much about machine learning and deep learning.
Yes.
Can you shed some light on those?
Absolutely. So machine learning is all about letting computers learn from data without explicitly programming them for every scenario.
Right. So instead of writing a super detailed instruction manual, we give the computer data and let it kind of figure out the patterns on its own.
Exactly.
So it's like giving the AI a set of examples and saying, okay, learn from this.
Yeah, learn by example.
And within machine learning, there are all these different approaches.
Oh, yeah, many different approaches.
Okay, like what?
So one common type is what we call supervised learning,
Supervised learning.
where we
Yeah.
provide the computer with what we call labeled data,
Labeled data, okay.
which is basically data that's already been categorized or classified.
So if we want to teach an AI to recognize like pictures of cats and dogs,
Yeah,
we'd show it a bunch of pictures labeled as cat or dog.
exactly. And it would learn to distinguish them.
So it uses those labels to build the model that can then classify new unlabeled images.
Exactly. And then there's unsupervised learning,
Unsupervised learning.
where we don't provide any labels.
Okay.
We just let the AI discover patterns in the data on its own.
So it's like giving it a puzzle and letting it figure out how the pieces fit together.
That's a great way to put it. So unsupervised learning is often used for things like clustering, where we group similar data points together,
Okay.
or for something called dimensionality reduction, where we try to simplify complex data by reducing the number of variables.
Okay. This is all fascinating, but what about reinforcement learning? I hear that one a lot too.
Yeah, so reinforcement learning is all about learning through trial and error.
Trial and error.
It's like, training a pet. You reward good behavior, discourage bad behavior,
Right, right.
and the AI interacts with an environment and learns which actions lead to rewards
Okay.
and which ones lead to penalties.
So it's figuring out how to maximize its rewards. That sounds like a pretty powerful approach.
It is powerful, and it's been used to create AI that can do things like play games at a superhuman level,
Wow.
control robots in really complex environments,
Really?
even optimize financial trading strategies.
Okay, so we've got supervised learning, unsupervised learning, reinforcement learning.
Yeah,
It seems like machine learning covers a lot of ground.
it really does. It's a very broad field.
But what about deep learning? Where does that fit in?
So deep learning is actually a subfield of machine learning
Okay.
that's been getting a lot of attention lately.
I've heard, yeah.
And it's all about using artificial neural networks,
Okay.
which are inspired by the structure of the human brain.
So it's about mimicking the way our brains work.
In a way, yes.
That sounds super futuristic.
It is pretty cool.
Yeah.
But these artificial neural networks are much simpler than the human brain.
Okay.
Think of them as like networks of interconnected nodes
Okay.
that are organized in layers.
Layers. Okay.
And each connection between nodes has a weight that determines its strength.
Gotcha. So information flows through these layers of nodes, and the connections between the nodes determine how that information is processed.
Exactly.
Okay, I'm trying to picture this.
And during training, those connection weights are adjusted based on the input data.
Okay.
So the network gets better and better at producing the desired output. And what makes deep learning so powerful is that these networks can have many layers.
Oh, so that's where the deep comes from.
Exactly. The more layers, the more complex the patterns the network can learn.
Okay, so the AI is actually like understanding the data, not just memorizing patterns.
You're getting it. And this ability to learn these deep representations is what's driving the success of deep learning.
Wow, I never realized how diverse and powerful these machine learning techniques are. But with all this talk about building smarter and smarter machines, it's hard not to think about the bigger picture.
The bigger picture, yeah.
What about the impact of AI on society?
Right.
What are some of the ethical considerations we need to keep in mind?
That's a great question, and one that AI researchers are grappling with more and more. As AI becomes more powerful, we need to be incredibly thoughtful about how we design and use it.
I can see that. It has the potential to like make our lives so much easier, solve some of the world's biggest problems.
For sure. Imagine AI helping to cure diseases,
Right.
combat climate change,
Yeah.
improve education for everyone.
The possibilities are really exciting.
They are.
But on the other hand, there are all these concerns about, AI taking over jobs, making biased decisions, even being used for harmful purposes.
Yeah, those are real concerns. We can't ignore them. We
Yeah.
need to be very deliberate about building AI systems that are aligned with human values.
That are fair and unbiased,
Exactly.
and that are used for good.
Absolutely.
It's well said. This has been an incredible journey so far. We've covered the history, the core concepts, the different flavors of machine learning, and you've really helped me see the bigger picture of AI and its impact on our world. But now I'm curious, what about robotics? After all, robots are kind of the physical embodiment of AI, aren't they?
That's a great point. And yes, robotics is where AI gets to kind of flex its muscles in the real world.
Okay,
Building intelligent robots presents a whole new set of challenges and opportunities.
I bet. So let's step into that world right after the break.
Sounds good.
All right, so we're back and ready to step into this world of robotics. It's funny, we've been talking about AI this whole time,
Yeah,
but it feels like things get really real when we start talking about robots.
it definitely does. Robotics is where AI kind of steps out of the virtual world and interacts with our physical reality.
Right, exactly. It's not just lines of code anymore. It's like
Yeah,
it's metal and circuits moving around in the real world.
exactly. And it brings a whole new set of challenges.
Well, I've always been fascinated by robots, I have to admit. I mean,
Yeah.
there's something both amazing and a little bit unsettling about a machine that can, move and act in the world.
I know what you mean.
It's like, it's cool, but it's also a little bit creepy.
Yeah, it definitely blurs the lines a bit.
It does. So, okay, we've got these intelligent algorithms, right?
Uh-huh.
But building robots that can operate effectively in, messy real world environments, that
Yeah.
seems incredibly complex.
It is. It really is. I mean, they need to be able to perceive their surroundings,
Right.
make plans, execute those plans, all while dealing with unexpected obstacles.
Right. It's not like programming a robot to work on like a factory assembly line
Exactly.
where everything's controlled and predictable.
Right. It's a very different ballgame.
So real world robots need a lot more like flexibility and intelligence
absolutely.
to navigate the chaos.
Yeah, the real world is full of surprises.
For sure. So what are some of the biggest hurdles, in creating these intelligent robots? What are the things that are tripping researchers up?
I think one of the biggest ones is perception.
Perception. Okay.
Robots need to be able to see and make sense of the world around them, right?
Right. So like us, they need to understand their environment.
Exactly. But for robots, that involves things like computer vision,
Okay.
where the robot has to actually interpret images from cameras.
Okay. Yeah. So translating those pixels into something meaningful.
Exactly.
Wow. That's a lot of information to process.
It is. And sometimes they even need natural language processing so they can understand spoken commands.
So it's like giving a robot a set of senses
Yeah.
and then teaching it to interpret all that sensory data.
Yeah,
I
exactly.
can imagine that's a huge challenge in itself.
Oh, absolutely. And then you have the challenge of planning and decision making.
Okay, right. Because it's not enough to just sense the world.
No, not at all.
You have to figure out what to do about it.
All right, so the robot needs to set goals, figure out how to achieve those goals,
Mm-hmm.
and then adjust their plans as needed, on the fly.
So it's not just reacting to the environment, it's being proactive, right? Making decisions and taking actions.
Exactly, exactly.
Like a chess player thinking several moves ahead.
That's a great analogy.
So they need to be able to think strategically.
Yeah, and that often involves complex reasoning about time and space,
Yeah.
cause and effect, all things that we do naturally.
Yeah, like without even thinking about it.
Yeah, but it's super difficult to program that into a machine.
Right, because we don't even fully understand how our own brains do it.
Exactly.
But it's not enough to just think about it, right?
Well,
The robot actually has to act. It has to move.
right, and that's where things like motor control and coordination come in.
Okay, motor
The
control.
robot has to be able to translate those plans into precise physical movements.
This is all so mind-boggling. Building intelligent robots really does seem like this incredible feat of engineering and computer science.
It is. It truly is. It's a really interdisciplinary field, drawing on expertise from, all these different areas.
Yeah, and it's advancing so rapidly.
It is. New breakthroughs happening all the time.
It's amazing to think about where this field could go.
For sure.
It feels like we're just scratching the surface of what's possible with robotics.
I think so too.
But as we've talked about before, with great power comes great responsibility.
Always.
So what are some of the ethical considerations that we need to keep in mind as these robots become more intelligent
Yeah.
and more integrated into our society?
That's a huge question. And, Ethics is a huge part of this whole conversation around AI and robotics.
Right.
We have to be thinking about things like
Key
safety.
safety, yeah.
How do we make sure that robots don't harm humans, right?
Right, because that's a real concern.
Yeah, and how do we make sure that they're used for good and not for malicious purposes?
It feels like we're kind of writing a new social contract. Figuring out how humans and these intelligent machines can coexist.
Absolutely. And these are conversations that need to involve everyone, not just scientists and engineers,
Right.
policymakers, ethicists, the public at large.
Yeah, because AI and robotics aren't just technical fields.
No,
They're really deeply intertwined with human values and societal implications.
for sure. And the choices we make now will have a huge impact down the line.
Yeah, on how these technologies shape our world.
Absolutely.
Well, I have to say, this has been an incredible deep dive into AI.
Oh, it's been fun.
I feel like I've gone from, AI curious to having a much better grasp of the fundamentals, the challenges,
Yeah.
and the just enormous potential of this field.
Yeah, there's a lot to explore.
And to our listeners, thank you so much for joining us on this exploration of AI.
Thanks for listening, everyone.
We hope you've come away with, a sense of wonder and a thirst to learn more,
For
because
sure.
the world of AI is constantly evolving. So keep learning, keep exploring, and who knows, maybe you'll be the one making the next big breakthrough.
You never know.